Look closely at this robotic arm. It moves with terrifying, elegant speed, stopping exactly 1/20th of a millimeter from a pristine smartphone screen. It repeats this motion every 3 seconds, 24 hours a day, 365 days a year. Most people look at this machine and see the future of automation. They see the towering logo of a multi-billion-dollar industrial giant painted on the steel chassis. They assume that this giant, the company whose name is flashing in tech headlines, is the one pulling the financial strings of global manufacturing. They are completely wrong. The multi-billion-dollar robotics company actually has a terrifying secret. They do not control their own destiny. In fact, if a single, obscure factory in Japan decides to stop shipping one microscopic component, the entire global robotics industry grinds to a screeching, paralyzed halt within 48 hours. The famous brands you see on the factory floor are just a beautifully engineered illusion. The real money, the absolute ironclad monopoly, belongs to a silent cartel that almost no one outside of elite industrial engineering has ever heard of. Over the next few minutes, we are going to strip away the polished yellow and orange paint of the world's most advanced machines. We will uncover the hidden bottleneck that dictates global trade, the secret reasons why Silicon Valley cannot break into heavy automation, and the invisible engineering cartel that secretly owns the hands of the modern world. To understand how this invisible machine works, we first have to look at what the world thinks it sees. When a massive car manufacturer builds a new assembly plant, they spend hundreds of millions of dollars on fields of mechanical arms. These machines are beautiful. They pierce through cold steel, weld frames with blinding flashes of light, and lift entire truck chassis as if they weigh nothing at all. Naturally, we assume the value lies in the brand of the arm. We assume the profits flow entirely to the company that designed the sleek outer shell. But if you look closely at the financial balance sheets of these massive robot manufacturers, something doesn't make sense. Their profit margins are surprisingly tight, often hovering in the single digits for the physical hardware itself. How is that possible? How can a piece of technology that defines the cutting edge of human civilization struggle to generate the eye-watering margins of a software company or a luxury brand? The answer lies in a fundamental misunderstanding of what a robot actually is. A robot arm is not a product. It is a collection of raw liabilities. Think of it like this: if you buy a luxury sports car, you are paying for the badge, the prestige, and the design, but if the engine breaks down every 50 miles, the car is worse than useless. It is an expensive piece of driveway art. In the industrial world, this reality is multiplied by a factor of thousands. A factory manager does not care about the sleek design of a robot arm. They do not care about the brand's marketing campaign. They care about one thing and one thing only: precision that never dies. If a robot arm experiences even a fraction of a millimeter of physical play, a tiny, microscopic wobble caused by a worn-out part, the entire production line is ruined. A batch of 10,000 smartphones will have misaligned screens. A fleet of electric vehicles will have faulty welds. The fear of this microscopic failure is what drives the entire economics of the industry. The real product being bought and sold is not automation, it is absolute mechanical certainty. And that certainty cannot be manufactured by just anyone. This brings us to the first major revelation. If you crack open the heavy steel casing of any major industrial robot, regardless of the brand name stamped on the outside, you will find the exact same beating heart. You will find a specialized component called a strain wave gear, often referred to by engineers as a harmonic drive. To the untrained eye, it looks like a simple cup of flexible steel with teeth carved into the rim. But in the world of high-precision physics, this component is a mechanical miracle. It allows a massive, heavy machine to move with zero backlash, meaning there is absolutely no free play, no wiggle room, and no mechanical hesitation when it stops. Without this specific gear, industrial robots would be clumsy, shaking giants. They would be completely incapable of assembling a microchip or painting a car door. Here is the twist. Manufacturing these gears requires a level of metallurgical science and machining tolerance that is almost frighteningly difficult to replicate. The steel must be flexible enough to deform millions of times without cracking, yet strong enough to support tons of industrial force. Because this engineering challenge is so severe, a single Japanese company historically locked down an estimated 70 to 80% of the global market for these critical gears. Think about the sheer scale of that economic capture. The famous robotics giants are completely dependent on an obscure supplier to build their machines. The brand names get the glory, but the precision cartel gets the margin. This hidden bottleneck changes everything we think we know about corporate competition. We are taught to believe that if a market is profitable, a competitor will emerge to drive down prices. We assume that a software giant from Silicon Valley or a massive tech manufacturer could simply build their own robotic arms and destroy the legacy incumbents. But they can't, and the reason why is an economic moat made of specialized metal and decades of institutional memory. Imagine a massive tech company deciding to build its own industrial robot. They have the best software engineers in the world. They have billions of dollars in cash. They write an algorithm that can control an arm with flawless artificial intelligence. They build the prototype, and then they realize they need 10,000 harmonic gears to launch their first fleet. They call the precision cartel, only to find out there is a 2-year waiting list. Even worse, the cartel's top-tier production capacity is already legally locked up by the legacy robotics companies through exclusive, decades-long supply agreements. The tech giant is trapped. They can try to build their own gear factory, but they quickly realize that copying 50 years of proprietary metallurgy secrets isn't a matter of money. It is a matter of time. The legacy robot manufacturers aren't protected by their software, or even their brand name. They are protected by a physical, real-world monopoly on precision components. They have weaponized the supply chain to ensure that no one else can even enter the race. But the economics of this business go even deeper than the initial purchase of the machine. The true genius of the industrial robotics business model is how they turn a one-time hardware sale into a multi-decade financial trap. When a factory installs a line of robots, they aren't just buying machines, they are fundamentally altering their corporate DNA. They train their entire engineering staff to code in that specific robot's proprietary language. They build their physical assembly lines around the exact dimensions of that specific arm. This creates a psychological and financial phenomenon known as high switching costs. Let's look at a practical example. Suppose a rival robot manufacturer approaches a factory manager and offers a new machine for 20% cheaper than their current fleet. On paper, it looks like a massive saving, but the factory manager will almost always say no. Why? Because the cost of ripping out the old infrastructure, retraining hundreds of engineers, and risking a single week of factory downtime to test the new system will cost 10 times more than any savings on the hardware. Once a robot manufacturer gets their machine onto your factory floor, they have effectively captured you for the next 15 to 20 years. You are locked into their ecosystem. And this is where the real money finally changes hands. Through the highly lucrative, high-margin world of spare parts, software upgrades, and proprietary maintenance contracts. The hardware is just the ticket into the theater. The subscription to stay in your seat is where the real wealth accumulates. Investors look at this dynamic and see an absolute goldmine. They see a business model where revenues are incredibly predictable, where customers are trapped by their own operational architecture, and where the barriers to entry are practically insurmountable. This is why traditional industrial companies are valued so highly by institutional capital. They aren't volatile tech stocks that can be disrupted by a couple of college students in a garage. They are infrastructure giants rooted in the physical reality of global trade. But no empire lasts forever, and the greatest threat to this precision cartel is not a new mechanical competitor. It is a fundamental shift in how intelligence is distributed. Right now, we are seeing the early stages of a profound software revolution. For decades, robots had to be mechanically perfect because they were completely blind and dumb. They simply executed a pre-programmed script. If a part was off by a millimeter, the robot couldn't adjust, it simply crashed. Therefore, the mechanical components had to carry the entire burden of precision. But what happens when you add low-cost, ultra-powerful computer vision and real-time artificial intelligence to the mix? Suddenly, a robot doesn't need a $100,000, hyper-precise Japanese gear to do a delicate job. If the robot's vision system can see the object and its AI can adjust the arm's trajectory 10,000 times per second, it can achieve perfect results using cheaper, less precise hardware. The value is rapidly shifting from the physical joint to the digital brain. If this software layer becomes standardized and open source, the massive physical moats protecting the legacy giants could begin to evaporate.